is going to be Charles Miller. He is the president of Space Policy Consulting Incorporated and the president and CEO of Constellation Services International, a member of the board of directors of the Space Frontier Foundation, and he led the public-private partnerships section of the NSSO's research laboratory. And I believe he also spoke yesterday, so you may already be familiar with him. So, ladies and gentlemen, Charles Miller.
Thank you, Ben. Just a little correction, the bio that's in the pamphlet is about 5 years old. So I am no longer the president of Space Policy Consulting. That's my old consulting firm. I went to work at NASA for 3 years. I've spent a good deal of time with James Royther as NASA Senior Advisor for Commercial Space, and I am the president of Next Gen Space LLC right now. So I left NASA in January and have set up a consulting shop in Virginia. The bio on the website for the conference is accurate and up to date. So, I have the pleasure of replacing Lynn Harper, who is a dynamo, and sorry she can't make it. The purpose of today's panel is, and before I start, and I'll introduce everyone and get in the purpose, I actually was told that we're going to have a short announcement, a special announcement. Desiree from the Foresight Institute here has a brief announcement. Desiree Dudley, she's Director of Development and Outreach at the Foresight Institute. So I'd like to just bring her up here and she'll make a quick announcement and then we'll start the panel.
Good afternoon, everyone. So my name's Desiree, and I work with the Foresight Institute. We are dedicated to advancing beneficial nanotechnology and other emerging technologies that include space, biotech, artificial intelligence, and we are starting this fantastic new youth outreach project this summer. We're completely bootstrapping the project. This project is sending book sets from top New York Times selling authors such as Peter Diamandis, his book Abundance, some of you may have heard of it, Sonia Arison's 100+, Ray Kurzweil's Singularity is Near, and classics such as Eric Drexler's Endless Creation. We are sending these books to the top 300 science, engineering, and entrepreneurially oriented college clubs, gifted youth programs, and STEM high schools here in the country in the next month. And as a direct result of me being here at this conference, we've actually started discussions with Space Frontier Foundation to include High Frontier. And if that turns out, that's going to be really fantastic. And we may also be working with Teachers in Space on some level to reach out to the STEM teachers that they have identified over the last year. So I'm really excited about this. And we are hoping to bring these students into our communities a bit more and to incentivize them to actually read these books, you know, and start talking to each other in their communities. They're already self-selecting here to want more community. We're also attaching to it an essay contest with a few different essay questions to bring them back into our communities and so that they can meet all of you. There was a panel on STEM recently, and one of the things that's recently been identified is that there are a couple of big factors that keep people in science and engineering. One is just really being inspired by great teachers, and the other is having the regular support of a community. And I think a lot of times, you know, when you're in college and you're working on some hard physics problem, you know, sometimes it seems really hard and you might actually just give up and go into another major. But if you are engaged in inspiring communities like the ones that we have here, you have a lot more potential to continue and expand. So we're doing this, and we're inviting all the organizations that are working with us to put free promotional materials into the book boxes that we're sending out to these clubs, and that's pretty much it. I hope you all can be a part of it. Oh, one thing I wanted to mention, actually, special thanks to Ruben Metcalf, who's here in the audience. He has the group idreamofspace.com, and he's actually also going to be contributing interns to our project for the next month. So thank you all very much, and I'll talk to you about something completely different in a minute.
Okay. So thank you, Desiree. So the panel today that we're going to be talking about is approaching the tipping point. And Malcolm Gladwell did a book recently that popularized the word tipping point, and it's talking about exponential growth, and you reach a tipping point and all the conditions are there and growth takes off. So in this panel we're going to discuss what technology paths are critical to the success of NewSpace. What technologies in NewSpace will allow various different areas maybe to take off in a tipping point. So the group we have here, I'm going to introduce, and then I'm going to introduce them all, and then they'll briefly let them say about 5 minutes of remarks, and then we're going to have a discussion. So first up is Mark Bunger. Mark is the research director at Lux Research with 20 years of international business strategy experience as a management consultant, technology analyst, entrepreneur, and innovator. He has advised more than 40 Fortune 500 companies, led hundreds of engagements, authored over 60 reports and publications, and lectured frequently at conferences. His work is figured in leading media outlets in U.S., Europe, CNN, PBS, and many others. He's published in Biotech News, American Chemical Society, Nanoletters, and other technical regional trade journals. We also have with us Desiree, who you just met. She's the Director of Development and Outreach at the Foresight Institute. It's a think tank focused on AI, biotech, nanotech, and other life-changing developments. She's is selectively facilitating in-network relationships between scientists, engineers, entrepreneurs, and venture capitalists. And she is a strategic and marketing and business relations consultant who has helped many companies, including Skyphrase, Invivokines, One Nano, and Stanford University. Then we also have Todd. Todd Meerrose is the founder and general partner of Talos Ventures. Over the last 15 years, Dr. Meyerrose has led a successful career in regenerative medicine, completing graduate research in craniofacial biology and the development at the University of Southern California and molecular cell biology at the Washington University of St. Louis. He has helped develop therapeutic interventions for genetic disorders, wound healing, and bone marrow transplantation. He completed his postdoctoral study at the Whitehead Institute in Boston, where he launched several successful companies, accelerating the development of emerging technologies in therapeutic intervention. And he recently formed a wonderfully named consulting firm called Evil Genius, and leverage venture capital group to provide venture funds, microloans, and executive mentoring sessions. And he's currently focused in technology sourcing and commercialization within the NASA network of scientists and engineers. He's also involved in philanthropy through various national and local charities such as Challenge Athletes Foundation and the Leukemia and Lymphoma Society. And then you got the benefit of listening to Dr. James Royther. James is the Deputy Director of the Space Technology Program, and it's a rare occurrence that you'll get him in a suit and tie. So compliment him on his dress, because you won't see it in him much in dressing up for audiences. So I'd like to kick it off. Who's first up? We've got the slides. Who's first up? Mark? Welcome to the podium, Mark Bunger.
So podium sounds like a lot of prepared remarks and slides and things like that, and I was kind of seeing us on the couch just talking a little bit. But we were asked to talk about three things in preparation for this panel to kind of get things started. One was the value. Why are we here? What value do we see in this meeting? One was, how does this community attract more users? And finally, what can the community do to stimulate demand? So in my context, the value that I see in this, first, is probably like a lot of you. I just have always been really interested and passionate about space and would love to find a great way to work with it and make it more of my life and my career. But, you know, like a lot of people that aren't in this room, practical things come in the way. So I started out, I was studying, intending to be an aerospace engineer, came across a unit in biochemistry that I hadn't really planned on taking and thought, this is fascinating. And that totally pivoted my career towards biotech. But I've still always had this passion for space. So I would love to find more things that make sense and are relevant to my clients and the work that we do. So a little bit about my company then. So Lux Research is a group of about 80 people. Most of the research team is scientists and engineers. And we look at emerging technologies in every area except software. So we don't do Twitter and things like that. We look at advanced materials, new polymers, bio-based polymers, nanocomposites, new battery chemistries, new types of solar cells and things like that. We write about that for non-technical investors or semi-technical investors. Most of them are what are called the Innovation 1000. So that's the 1,000 companies in the world that spend the most on R&D as a percentage of their revenue. So it's a lot of things in chemicals, in materials, in manufacturing, and what they want from us is the next big thing, the next new thing. And space is really hard. It's a great place to find the next new hard thing. So I like space, as I think John F. Kennedy said, you know, we go there because it's hard. That's why we're interested in it. And we really like really hard stuff. So I came to the business plan competition. I was a coach for one of the business plan teams. And yeah, I've been doing these types of events for a number of years. And if you go back, say, 5 or 10 years, you'd come to a conference like this and you'd find things were either very, very mundane, and really so tied to the space industry they couldn't be brought out, or so really, you know, let's colonize the moon, let's you know, go to Pluto next year, and that type of stuff that was really not realistic. So from an industry perspective, there wasn't a lot there. This year, I think that's exactly, you know, the opposite is the case. All of the business plan teams that we saw had great applications that really are near term. Some of them are really, really needed, not just in space, but elsewhere, like the biotech firms we saw. Some of the other ones really enable space for a new group of people. So this leading into the how do we attract users? I think there's a really, really interesting confluence going on right now, and when we talk about the tipping point, I think this is what drives it. So tipping points are not just like you trudge along and trudge along and trudge along, and one day, you know, things take off. The reason these tipping points, these sudden events happen in technology is because different technologies come together. And the lines that I see crossing in space right now are the decreasing cost of launch. That's great. It's not going fast enough on its own, but it's primarily the increasing value or the increasing function per kilogram that you can get. So in data, in terms of strength per kilogram, in terms of data per kilogram, in terms of all the other things that we think of function and value that something can provide, that's going up at a really rapid rate. We can put more and more and more into a kilogram or into a gram, and that's where we're going to see a lot of these applications really take off. So the intersection of those two things, I think, is the catalyst that's going to make this really, really change, and the pace of change that we've seen in the past, slow government program, leading to commercialization, that's why I think we're at this tipping point. So I think that in and of itself will attract a lot of users. And the last thing about stimulating demand, back to what I said about the startups, the applications that they're pursuing have really, really practical value. So Pine Aerospace, for example, replacing a very expensive process that oil companies are already doing today and are going to have to spend more money doing tomorrow, that's a great way to attract demand. Looking at the structures that Space Ground Amalgam is looking at with basically being able to rigidize polymers, large structures, and make those very, very portable, there are a lot of applications for that aren't just space-based. But if you can do it in space, you can certainly do it in a lot of other environments. So those are my 3 things. I hope that's been a useful intro and given you some things to think about. Who's next? Thanks.
Okay. Desiree, you're next up.
Hey guys, how's it going? So this is actually my first NewSpace conference and my first space conference ever, which has been very exciting for me. Actually, there's a lot of great people here and a lot of connections that I've made, which are absolutely wonderful. I first got here, I've been working with the Foresight Institute for about 1.5 years, and I met Baron Soka on the board of directors who said, hey, Desiree, we're looking for some new faces here at the conference. You should come to this panel. And so I thought, okay, great. I'll come and check it out. What I do at Foresight is a lot of fun. I mean, my favorite part of my job is basically going in and talking to different scientists and engineers about whatever wacky technology they've been working on for a while. And if they're missing something on their team, or if they're starting to develop a technology where it's getting to the point where it could be ready to turn into something marketable, I like to connect them up with the right people that can help them make that happen. And this is a wonderful thing. We have 30,000 people on our mailing list and in our network that are all interested in emerging technologies. And one of the reasons why I'm really here is because in 2.5 days at a wonderful space conference, one of the things I've noticed is actually there's been very little mention explicitly of nanotechnology, for example. I noticed that so I was doing my homework for the panel, and I said, oh, wait, the NASA Tech Roadmap is actually on the list as something that we should be talking about. I should probably go check that out. Actually, also for any of you, especially if you're a space enthusiast, but you're not particularly familiar with the details of NASA's technologies, this information is publicly available on the web. So the most recent version, I think, is April 2012. You can just go look that up. The section on nanotechnology alone is 27 pages, and really it's just an overview. So hopefully we'll be talking more about that, and I would love the chance to talk to you all more about the possibilities that can emerge.
Todd?
Thank you very much. So first of all, thanks for inviting me here. I'm very new to the space industry, so only literally 4 or 6 months. So I've learned a lot already, and I'm anxious to learn a lot more. I think Mark gave a nice summary, so I'm going to keep this very brief. I'm anxious to get on to the panel discussion part. As you heard, I started my academic career actually a little bit before that at the University of Kentucky. And all of my research from then on has been very application-based. So the things that I'm really interested in developing as emerging technologies are things that have application to a problem. So I like creating solutions through disruptive technology. So my first project at University of Kentucky was this obscure yeast mating type that happened to be an opportunistic infection in HIV patients. So kind of take an emerging technology, then apply that to something that became a very big problem. After that, I bought my first pair of shoes and went to graduate school out in Los Angeles, and did a little bit of work out there in gene therapy and some bone marrow transplant modeling. Through that, ended up in Boston, ended up doing some consulting through biotechnology companies in the area. And that was when I was introduced to this whole spectrum of adjacent technologies that have been developed in places you wouldn't expect, NASA being one of them. You guys don't just make rockets, you don't just make spaceships, you make medical devices, you make data handling systems, you make a whole spectrum of technology that the average person, and myself included at the time, didn't know was being developed in here. So those are the things that now, as working in venture capital and private equity, those are the kinds of things that I like to look for, where you have a technology that's maybe going to an endpoint, but while you're on that path, you find all of these amazing adjacent applications for the technology you're developing. So I guess those are the things that I'm interested in talking about, and those are the things where I think you really have an opportunity to get private sector investment dollars, private sector technological expertise involved into this process, and really leverage the resources of a NASA, of a CASIS, of NanoRacks, of SpaceX, of all of these different institutions, and I'm sure I forgot 57 of them, but taking all of these large corporations with federal support in the private sector to fulfill a market demand for a problem. So I guess those are the things that I'm interested in having a panel discussion about, and I'd love to hear some input from the audience and sort of direct that conversation.
James, if you could answer related to the panel, but why are you here? What grabs your passion as getting in a career in space and tying it in? Interested in discussing with this group here today. It'd be if you haven't already said it, but encapsulate, that'd be great.
So I think I spoke enough, so I don't know if I need to add anything here.
Just summarize it again, 60 seconds.
So, well, let me take a different spin on it. Let me give you maybe a little bit of a background. While I have been involved in many NASA programs through the years, that were somewhat mission focused, in other words, go get this NASA mission done and develop the hardware, the nuts and bolts part of being an engineer. While I've been involved in that at various times in my career, I've always come back to doing technology development. I truly believe that one of the fundamental core reasons that NASA exists, along with other technical agencies within the government, is to do the job of taking the next step in maturing technologies, in innovating new concepts, in supporting the academic institutions to be able to do those activities where industry can't. If we don't have that pipeline of activities, support for academia, and the creation of new ideas, new concepts, innovation, supporting the people to do those things, and then taking those at least to the point where they have a chance of getting into the marketplace. I feel like, especially in the space enterprise, it's very difficult for that to happen. The cost of access to space is so extreme, even with some improvements that have occurred lately. It's still so high that most people can't get there if they are a garage entrepreneur that's trying to figure out how to do the next great thing. It's a very difficult environment. So to the extent that the government can help do that, that's what passions me.
Okay, great. And I'm just going to add a few remarks about why I'm here and my thoughts on the tipping point, and then we'll have a discussion, open up for discussion. The reason I'm here is I've dedicated my life to expanding human civilization across the solar system. I want to incorporate, as part of that, the entire solar system into our economic sphere of influence, but it's about expanding humanity, human civilization into the cosmos. It's getting off this planet forever. That is a audacious, grand purpose, and I'm willing to dedicate my life to it. I did it decades ago, and I love what we're up to, and technology is absolutely critical to that. And the only way we're going to do that is hit some tipping points in partnership between the best of private industry and the best of government, and doing, each doing what it does best, getting the roles and responsibilities right, and then working together. A little thoughts on this, says the subject of this being a tipping point. It wasn't mentioned, some of you know. I'm the co-founder of NanoRacks on the International Space Station. It's basically was created about 5 or 6 years ago as an idea, and spun out of my prior company, Constellation Services International, as its own company. And it's now at the ISS with over 60 payloads in backlog, and it's cash flow positive and doing wonderful. You can, if you're a college, you can get a payload on the space station for $25,000 and do real microgravity research. You can get there in as short a period as 9 months, and if you're a commercial company, you can do real research for beginning about $50,000. So an order of magnitude reduction in costs for getting, sustained microgravity research time, getting your data back, and having astronauts, partner with you on the space station. I am convinced that Moore's Law is coming, and it's coming in the form of CubeSats and nanosats, and it's going to disrupt everything. And those of you, and you see this reflected in the business plan competitions, and NanoRacks is like the first example of a profitable enterprise that's starting to disrupt this industry. And there's many more to come, and it's Moore's Law, and it's just leveraging that, what's going on in private industry, and the fact that NASA's doing Edison and Franklin, and it means that NASA's committed to this too, and leveraging it, and NASA Ames is the center of CubeSat technology within the agency. So without any further comments, I'd like to throw it up to down the audience. What are the top 2 or 3 technologies that are critical to advancing a tipping point? That you got a great audience here. There's people from NASA and other companies here who can invest in it. They might think of investing their corporate money in it, you got private investors, and you also have the deputy director of the space technology program. So what's the top 2 or 3 technologies? Go down, and then James will tell you maybe what he thinks too, but he may stay silent. We'll find out.
Okay, all right. I'd actually second what you said about CubeSats, nanosats, and that hardware platform. So one really critical factor that you always see when a new technology hits that tipping point, that could be the railroads, that could be computers, the things that we've just in our lifetime seen happen, is standards. So for railroads to really spread, they needed to have a standard gauge. So cars could go from road to road without having to say, well, we're going to have to lift this up and put it over on another set of wheels. If you look at the Port of Oakland, if you go back a generation or 2 ago, we didn't have standard shipping containers that would go from rail to truck to ship easily. You just pick it up and move it. You had to have hundreds of longshoremen lifting every single box off a boat and putting it on a truck or a cart or whatever. So the emergence of standards, the standard shipping container, was absolutely catalyzed and changed the shipping industry. And in this case, for computers, I think it was a lot of the hardware standards that came into place that then let software standards like HTML and things like that just take over. So when standards emerge, it basically makes it black boxes all the complexity for innovators to look at a new set of function, a higher level of functionality, and they can stop thinking about the gory details, and they can think about their idea or their concept. So I do think that CubeSats and nanosats, and basically the fact that this is now a high school project, if you can raise enough money, and more and more places can do that, that's a phenomenal platform for innovation. So that would be my top 3 choices right there, probably.
So I have to admit I'm a little biased. I work for a nanotech nonprofit, but I think.
Well, just just don't say nanotech. Tell us why, and
so,
a flavor of it.
So I actually think that I think one of the things that could really help us leverage what we want to do in the future is getting, and we're already starting to do this with the popularity around SpaceX, et cetera, but really coming back to the industry that's here on the ground and looking at the innovations that they've made. I think we have not been looking at that as much as we could be. A lot of times, with all due respect to NASA, they do a lot of their own research and they do partnerships. One company in particular that I'm actually thinking of is Zyvex. Some of you may not be aware of this company, but it's one of the first molecular nanotechnology companies that are out there. And you have to understand that bio and nanotech have gone through ups and downs in terms of popularity in the VC land. But when things are down and companies keep working on them, you'll see something come out of it later. Last year, Zyvex put out their demo Piranha unmanned surface speedboat. And we're talking about going to space, and I'm talking about speedboats, right? But this is a really fascinating speedboat. And the reason why it's fascinating is because it's made out of a hull that uses carbon nanotubes. And I don't know how familiar all of you are with carbon nanotubes. They're really strong, they're really light, it's great, but we've got a bunch of problems with them, and one of them is that they like to grow in all sorts of directions that we can't control. This is a huge problem if you want to use them to make things lighter and stronger. Zyvex has figured out how to make them grow in a certain way that they can use in a unique resin called they call it their Cantera technology, I think it is. And for the record, Zyvex doesn't give me any money to say this. But this is really awesome. What happened is they've got these speedboats that are going 3 times as fast as anything you've ever seen. They can go 1,500 miles, 40 knots, which is pretty darn fast. It goes so fast that they got some of the best captains on this boat once they made it, and they were getting sick taking it at the highest speeds that they could go across the water. And of course, then the military became very interested, and they started looking at it. And then Jim Von Eyre said, I need to go start looking at AI because I need to have something that's unmanned to use this boat, right? But if we can do this with boats and it's going faster than we can handle as human beings on water, what could we do with a technology like that going into space? I really think we need to look into partnerships like that a lot more and look at what we're doing to be more effective. And you said 3 things, but I think there's a lot of stuff embedded in there, so I'll just leave it at that and give it to Todd.
So I think I'll just want to echo what Mark said. I think a lot of his comments are spot on. the standardization, and I don't know if Peter Platzer's in the room, but the NanoSatisfy, I think he hits a lot of things that I really find interesting. There's standardization of your payload, there's educational outreach, which I think is huge and very important, and he's mounting sensors, okay? So I'm just gonna kind of leave it at that for now, but that ties into one of my three things. So I think you're talking about different timelines of development. So let's talk about sensors for, let's say, Earth observation. The minute you turn that thing on, you have a source of revenue. You have something that you can sell to people, whether you're talking about agricultural oversight, high value asset tracking. I mean, there's obviously, you know, the applications. So that's something that I think is very close to market. And a lot of the technology is already in place. You're already using it in satellites that are in orbit. They're already on their way up to the ISS. NanoRex, for example, I think has something in the pipeline. So that's sort of an immediate solution, something a little bit mid-market, 18 months to 24 months, medical devices. There's nobody on the planet that does remote medicine better than NASA. It's extremely remote medicine, but it has tons of applications here terrestrially. So for patient care in places that are not very accessible, you guys are producing a lot of stuff that's immediately deployable with very few regulatory disruptions because you've already used it, you've prototyped it, there's safety checks in place. The clearance pathway is very easy compared to a lot of other medical devices that you have to work with. So that's probably my second one. And for number three, I really like additive manufacturing. I think it's a bit far off, but as far as something that requires some patient R&D and some patient money with tremendous outlay in 15 years maybe, depending on application, and we can talk specifics if anyone's interested in this, I think that's a tremendous area of interest from corporate partnerships and from people like me in venture and private equity. So those are my three.
Additive
manufacturing.
What's that mean?
Fancy 3D printing.
Okay. Well, we know 3D printing. I think that, okay. So James, they think nanotech, biotech, standards, and 3D printing. What do you have to say to that?
So I would say that it depends on what you want to do. If it is low Earth orbit, if it is having a greater space enterprise in low Earth orbit, then it's one set of technologies that you really have to think about. If it's what you presented as your goal, which is colonizing the solar system with people, it's a different set of technologies that you really have to invest in. So we are trying to take, NASA's trying to take the holistic approach of saying, hey, we have to put some bets on all of these things, not just one set. I won't focus on the human colonization of the solar system. That's a great topic to talk about. Everyone gets really excited. We could talk about all the technologies involved. There are huge challenges and huge roadblocks, but I'll leave that and talk about the low Earth orbit. How can we create the market space so that everybody can have access to it and do all these great things? Just because the other panelists have sort of focused on that as well. If you take the standardization approach, I think that that's already happened. The reality is that's past the tipping point. Standardization of CubeSats, 1U, 3U, et cetera, has happened. The structures for those have, standardization has occurred. Even power for them, deployable solar arrays for very small CubeSats, it's there. I mean, people use them every day. Every year there are multiple dozens of CubeSats that are launched and are flying. And some of them are done by just students doing it with very small amount of funds. It's fantastic. However, in order for that small platform approach to actually become the mainstay of how everybody uses access to space and expands the application domain of that standardization approach, there's a few things that need to happen. One is that currently it's very difficult to control these spacecraft, these small spacecraft, once they're there. Big spacecraft use reaction control systems to actually maintain position, orientation very accurately. You need to be able to do that with these smaller spacecraft, which means either propulsion or reaction control systems that actually allow them to do that. We need to make the investments there, take that, allow that to occur, and all of a sudden it's going to transform everything. The second, the technology that I think is absolutely essential is low power communications. And by that I mean using laser communications as opposed to radio communications. Radio communications is great. It's what everybody has used in space for decades. Ever since we've gone to space, we've used RF to get data to and from the satellite. can't do that for small spacecraft, in my opinion, because the power consumption is just too much. So if you're really going to use those small spacecraft to do something essential or useful, you got to have great communications. Third technology that's essential in order for this to actually take off, besides communications and besides keeping the thing oriented, is just realizing, and I'll go back to what my colleague here on stage said, was having the next generation sensors, taking the sensors that we use for very large satellites today that point at the ground and pick up data, and using Moore's law to shrink those sensors down to the point where they could be put on these smaller assets. If you do those three things, it changes everything.
Did anybody have any comments or follow-up comments, and then we'll open to the audience? Go ahead.
Just wanted to add, if you're interested in 3D printing or additive manufacturing, I happen to be wearing some cufflinks that I made with 3D printing, my iPhone case. But most important, I also have some, you can touch it and look at it. But most importantly, is Aaron, the CEO of Made in Space, here? Okay, earlier in the week, actually one of the other coaches on the business plan competition is the CEO of a company called Made in Space that does 3D manufacturing in space. So.
Okay. Well, we're going to open it up to the audience. Please raise your hand. Do we need a...
I want to tell our online audience that we are also taking questions, and I'll be feeding them to our moderator, or if we have a breakdown there, I'll also be raising my hand to ask questions for you. So to our online audience, we are actually listening.
So, Al, right over here, microphone. Introduce yourself. And
Al Globus, San Jose State at NASA Ames Research Center. The CubeSats are well standardized. What about the larger sats?
There's multiple groups out there trying to standardize larger satellites, and by working on, for example, bus standardization, creating a fixed size bus that has a cheap commodity way of doing propulsion, cheap commodity ways of doing communications, cheap commodity ways of doing power. There are multiple groups that are working on that. The technologies are in hand. I don't think that NASA, per se, should play a role when, okay, those technologies are there. There are industries, commercial entities that could go out and say, hey, we're going to come together as a consortium and put together a standard. NASA would certainly play a role and help and participate in some of those interfaces to establish those standards. But I really believe that that's the domain of the competitive market to establish what that should be. That's the way it grew up in other industries. It should not be government-driven when you go to those larger platforms, in my view.
Okay, others? Any other questions?
I just
Gentlemen,
want to add
over
on to that real quickly.
Okay.
I think that's a crucial point, and not just relative to satellites, relative to any technology that NASA is assisting to develop. At some point, it's the role of NASA to help get over an insurmountable technological hurdle, and then it's up to the private market to demand how to apply that. And as he said, you have to put that under the Occam's razor of efficiency, right? Capital markets will demand a certain product, and if you're trying to force it in another direction because you have the institutional leverage, then you're not really externalizing your technology.
Okay. This gentleman, announce yourself.
Yeah, I'm Andy Quast from Northrop Grumman Corporation at Kirkland Air Force Base, working
One of
primarily
those
with
big satellites you can standardize.
No, actually, and I want to comment on both, because on a large satellite for the operationally responsive space office, we're developing the modular space vehicle, which is probably a fraction of what a satellite that size would have cost just 5-6 years ago. So we can mass produce these things and do some really interesting work by standardizing large satellites, and large size of a Volkswagen, not a size of a GPS. But also interested, James, in your comment on the control systems in the small sats and CubeSat range. Some recent technology was really looking at CMGs and things like that for controls. we're developing something called a reaction sphere, which is a floating magnetic sphere, which a single component, which is about a 1U size, is replacing what is traditionally done with 3 CMGs in order to get all 3 axes, because it's multi-axial. And so, I mean, I think we're taking technology beyond what is standard and starting to do some really high-tech stuff that's going to revolutionize, and not just Northrop Grumman, but a lot of the large and small satellite developers are working some real interesting concepts here, and it should be operational within about a year or 2. So,
Any comments on that? Next, there was no question there. Next question. This gentleman.
At some level, we've been using...
Introduce yourself, please.
Hi, I'm Paul Breed. I was one of the business plan competition entries yesterday for Unreasonable Rocket. You know, since the 40s, we've been using basically the same chemical propulsion, and you know, the most modern rocket today would not look unfamiliar to von Braun's team from the 40s. So I question whether the change, the question I really want to ask is, how much do you think technology really makes a difference versus a change in the way business is done in this, quote, space?
Great question. Panel?
Well, when people think about a lot of technological change, especially in the last 10 or 15 years or so, we think of Moore's Law as some kind of an ironclad rule of technological development, and it's not. You see that in a lot of, the way a lot of investors and politicians and others got burned in clean tech is because they assumed that once you've invented it, you just distribute it, right? You just roll it out like software. Once you've invented it, distribution cost is nothing. So the fact that any physical technology has a variable cost and it's generally pretty high is a big gating factor on its development. In the case of space, if you can't figure out how to make propellant that costs, you know, X amount per kilogram cost 0.X amount per kilogram, or in some other way just increase its you know, performance per dollar exponentially for a long time, then that's always going to be a problem for you. In silicon and basically chip design, it's very easy because the geometry of the chip, basically the size of the feature, literally translates into performance per square centimeter, per square millimeter, whatever. That's so far, as far as I can see, not the case in space technologies. So those types of things are always going to be a limitation. I can say on the positive side, I can give a very specific example of how NASA technology is helping that out in a different area. So you have probably heard about biofuels. You probably think of corn ethanol. And there's been a lot of talk about algae for biofuels, because algae grow a lot faster than any other organism that you could use to make fuels. Well, a lot of the companies that are trying to commercialize that have in mind the technology that's been used to cultivate algae for decades, and that is basically a pond. So cement or just a polymer-lined hole in the ground or something to grow algae is how they think about doing that. And that's great if you're making vitamins, because a couple acres you can make literally millions of dollars worth of product. But if you're making fuels, you can make a few dollars worth of product with the same area. So NASA started some work in the 70s around cultivating algae for fuels, and the configuration that they really landed on with in terms of scalability is taking that same algae cultivation infrastructure and putting it, basically just having floating bags in the ocean. You don't have to pay for land. A bag floating in the ocean is a lot cheaper than a cement pond drilled into the ground. There's no rebar, there's no concrete. You don't need to pump it because you've got motion from the water. You don't need to heat it up because the water is your thermal management. So all these technologies that NASA developed, there's a scientist based here in the Bay Area named Jonathan Trent. He's got a demo facility up in the San Francisco waste management facility in Bayshore. And he's basically, all he wants is to get that technology deployed. So there's not the licensing issues, there's not all the costs that you see with a lot of the other technologies that they're trying to commercialize. So this is, again, I think a great example of how you can, with some, some clever thinking, get a lot of that capital cost, that physical cost out of the system that otherwise would be a gateway. So I don't know if that means electromagnetic launches or something else for space, but something like that that gets that material cost out, that would be a really, really great breakthrough.
So I'll
Go ahead,
take a
James.
crack at it. Everybody thinks, rocket fuel is going to be, if we get the price of rocket, well, some people think that getting the price of rocket fuel down is going to help us. The rocket equation is going to tell you that, even in best case scenarios, you're going to have 70% fraction of your overall vehicle when it takes off is going to be fuel. So it's the major component. But if you look at launch vehicles, and I don't care what size you are, rocket fuel is a tiny, tiny fraction of the overall cost. It's irrelevant. It doesn't matter what fuel you use, even if you use a really expensive fuel. It is the operations of that rocket. It's building the hardware of the rocket. It's making a system where you could produce these things rapidly, and that there's enough of them that you could produce that it becomes a mass market. If you're producing one rocket a year, and you're flying one rocket a year, and you still have to have 100 people to produce that rocket, it's going to be very expensive. And I don't care how cheap or expensive the rocket fuel is. That's not going to be the driver. It's the hardware of the system. Remember, a rocket is one of the most high energy objects on the planet. You're putting more energy through that system than you are almost anything else that exists. That's not going to change whether you change the way you access space. And let's say we use lasers to heat up something, and we keep the laser pointed at it, or we come up with really exotic ways to get to space. It's still a high energy operation. And that high energy operation is going to require some serious engineering to get it right and make it reliable. And if you can't produce it in large quantities and fly large numbers of them, those costs are still going to remain high. My take is we're not going to apply Moore's law to rocketry. We're going to apply Moore's law to what we fly into space so that we could reduce those costs. I mean, that would help a lot. Where you can make a big difference on the rocket itself is look at the systems that are involved besides the propellant and the large items like the rocket engines. If you could produce rocket engines for cheaper and produce large numbers of them, that makes a big difference. If you look at the avionics packages of rockets, they tend to be very expensive and using very old technology. We need to start thinking about the avionics packages that are in a cell phone and put those on the rocket so that the costs come way down and it allows for very small rockets to occur. And then there's one last point, and this is critical, is that rockets require a place to launch it, and the people and infrastructure around that, as well as range safety, making sure the boats are out of the way, or making sure people are out of the way, clearing the launch site so when the thing explodes, because occasionally they do, you don't kill a bunch of people. That is a big problem. Launch availability and the infrastructure around launch is actually a huge deal. Anybody that runs an airport will tell you how expensive it is to run an airport. Running a spaceport is even more expensive by an order of magnitude. And so thinking about how to do launch without that infrastructure, without that, says, hey, carry it on the bottom of an airplane, fly your airplane over the water, launch. Those are the kind of approaches that you could do rapidly. You could do it whenever you want. You don't have to wait for the launch site to be available. You don't have to wait for it to be a sunny day. You can fly above the clouds and go launch. If you do those sorts of things, it makes a big difference. Don't focus on the rocket equation. Don't focus on the chemistry.
Any other further comments on his question?
So I completely agree that one of the biggest reasons why rockets they look fundamentally the same as they have for many years is because the fundamental physics that goes into rocket launch, we still have the same problems there. And you can talk about things like nuclear rockets and, quantum answers to this problem, but I really think that there are ways to shave a significant amount of money off the budget if you can do other things with nanomaterials and other things as well. So, oh, one thing actually I do want to say, there is, I think it's really fantastic that NASA puts so much energy into research and development, and I also think it's great that they will cut projects that do not seem like they can go to market. However, the technology has changed a lot in the last 25 to 50 years, and there are certain projects, there's certain research that is out there that some people haven't looked at these designs in 30 years, and they were killed because they weren't working in the 70s. But it may be the case that we can actually look at some of those old technologies that got dropped and see if they can apply to some of the technologies we developed in other areas, and I would really love to see that.
Old designs, new technologies.
Yes, and that synthesis there I actually think has a lot of potential. It would be really great. I think this is a great way to connect, kind of the older, more established, very knowledgeable generation, of space experts with some of the young people who are coming up who have all sorts of great ideas. So. Okay.
One of the things that I heard Paul ask that I just wanted to comment on is changing the business model. So I think there's agreement that focusing exclusively on technologies is not, and like the chemistry and stuff is not totally it, but I'll say that NASA and industry have already changed the business model. We've proven using the same technologies, but changing the business model can have a huge impact, and it's called, what Elon did a few months ago, was started, the US government had COTS for demonstrating a new business model, COTS and CRS. We are doing funded Space Act agreements that NASA has this ability called Other Transactions Authority to do streamlined capability development, and it proved we can do it. For about $400 million, SpaceX, in partnership with NASA, demonstrated a brand new way of developing new capabilities using basically all existing technologies. For about $400 million, they got the Falcon 1, the Falcon 9, multiple new engines, and demonstrated the Falcon 9 and Falcon 1 technology. And NASA actually did a cost estimate using NASA's traditional cost estimating tool of what it would have taken to develop that capability using our traditional NASA approach. And the estimate was $3.9 billion. So changing the business model can have nearly an order of magnitude effect in some cases. And this shouldn't be news. Clayton Christensen's disruptive theory really talks about changing the business model is the key. If you're using the same business model, you're not going to get the full impact. So next question. This gentleman over here.
You talked about new business models, and that SpaceX has this new business model with NASA. But as it pertains to standardization, the SpaceX business model is a very vertical model where they do most of the services from top to bottom. Mm-hmm. And that does not promote standardization. What can be done to try to push companies in the new space and in the old space arena, or traditional space, to outsource some of these services, life support, command and control, communications, these things that are not core to their business that would promote the standardization of the industry that we're talking about today?
I'll take a crack first. Charles, you're familiar with this problem. When he was working at NASA headquarters with me, we talked a lot about this. The fact of the matter is that and everybody in this room knows it, that access to space and doing things in space is a fairly inelastic situation still, which means that if you, let's say, shrink the footprint of something, the size of something to go do a specific application, and you reduce the cost of launching that thing into space, and you do all these things that you think are going to help expand the market, some of the traditional things we do in space, we do a certain number of them, the communication satellites, things like this. We do a certain number of them. It doesn't matter how much they cost or how cheap they become. It's not going to significantly increase the number of those things that you do. And so what that means is the overall revenue of the space market goes down even if you're cutting the cost of the individual components to go into it. The number of things that you put into space doesn't keep up with that reduction in cost of the components that you're doing, such that the total revenue for everything we do in space actually still heads down. You have to get that to a tipping point where suddenly new markets emerge. Now, that is why the vertical model that SpaceX has used has worked, and why commoditization or standardizing interfaces hasn't worked yet. Because let's talk about that avionics package that I was referring to earlier. There's several people, several companies are out there that build avionics packages for almost everything that flies into, as far as the rocket is concerned. You know, the avionics package that controls the rocket as it goes up into orbit is basically unchanged. It's still using technology that's 20 years old, and it's actually using hardware components that are 20 years old. And it's built by the same companies, and they keep stamping out the same copies of them. Each of them costs, you know, $200,000 a piece, and if you're trying to launch a small rocket, they weigh too much as well. So it's difficult to do that, and there's no motivation for them to actually shrink that or reduce the cost of that and make it more affordable, because they're always going to fly the same number of them. It doesn't matter, right? So unless you get to a point where the whole market says, hey, there's a new paradigm out there, there's 10 times the market availability if you go after it by reducing costs, and you prove that that's the case, then you're going to change it. Instead of thinking about it that way, I think that the approach that the NewSpace community is taking by looking at the smaller platform, making it more capable, is going to enable that to occur. And it will transform things. Instead of trying to say, hey, let's make common interfaces for everything out there and trying to reduce the overall cost of every one of those components, why don't we look at the CubeSat phenomenon and expand around that. Make the CubeSat more capable, make all of the things around that more versatile, so it could do more things, so it could open up markets, and so that the other pieces will become standardized as a follow-on. That's the way I think about the problem.
I was just going to give two models, I guess, from the history of technology and the history of industry. The first one about, you mentioned vertical integration. So you have like pretty much, you know, soup to nuts integration. One company does everything. And that's a very typical at this stage of this industry's evolution. So if you look at automotive, and you go back to like the 1920s to about the 1940s, a car maker had its own rubber plantations. It had a farm to grow the pigs to feed the workers. It had, I've been to the place where Volkswagen had the pig farm. So the sausages were very good. So that's actually not atypical, and it's something that I think would be worthwhile for the community here to look at. How has that evolved in other industries, and what can we do to accelerate and find some shortcuts there? The other one is about just evolution generally, and this, again, applies to even biological evolution. So if you look at how fast can you do fruit fly experiments, if you're doing genetics, you get fruit flies because they last, you know, their generations are very short. You don't do genetics experiments with elephants or with people because it takes too long to get to the next generation. Right now with space, we have very, very long generations because we don't have that many individuals to work with. So that's something else I think is really exciting about the CubeSat as a platform for innovation, because it allows you to do experimentation, and if it doesn't work, it's okay because we're gonna, you know, we've got another set of them coming along. So looking at some other places where standards have, you know, kind of meandered around and then, you know, hit that slipstream where they just goes really, really fast. There are a lot of things that we have, you know, in our pockets on the tables here, like the USB port. You know, remember how hard it was to get a printer to work with your computer, and like the printer maker would blame the computer would blame the software would blame the hardware. That was terrible. And now we've got a lot of things that are plug and play. So I think it'd be worth it, again, for the community to look at some research programs where we could look at those past technologies, how they evolved, how they hit a standard, and then what happened after that standard evolved, to choose some of the types of things, like you were mentioning, propulsion and other types of areas where if we had this, we could do a lot of other stuff and then focus some energy on that.
I'd like to take a quick step even back before that and say, so how do you facilitate this, and what's the choke point? In my perspective, from just the limited amount of work I've done over the past half a year, one problem is the tech transfer system within the NASA network. Every base has its own tech transfer. I don't know if you know this or not. You have a tech transfer problem. So you have way more technology and way more intellectual property than you can handle correctly. And it's not a problem that's exclusive to NASA, because as I've worked with universities over the years, they have the exact same problem. So if you want to talk about how NASA could make an enormous economic impact, and I know you guys are technically proficient at handling large amounts of data, which is what we're talking about, design a database handling system that would expedite technology transfer and roll it out through universities. Create a platform system to handle this sort of patent work so that guys like me could filter and sort according to what we wanted to find it efficiently, match it with small disruptive technologies to improve their process. It would work for universities, it would work for you, it would work for large corporations. Design that sort of platform. The other thing that I would say is put this technology, to also put this technology in the hands of more people, is this educational outreach aspect of it. So I know Eric Elias is here. He's in the back. He has a company called Pegasus Hardware. What they do is they create small modules of hardware and software that go out as learning kits. They deploy to 3rd graders all the way up through 12th graders, and they teach them rudimentary systems of programming. You can start with 3rd graders with very visual programming languages such as Scratch. There's a small, very simple microcomputer called a Raspberry Pi. You can learn how this works, and then by the time you have a high schooler, he's moved from Scratch to Arduino up to programming in C, and you have a new software engineer who might take a piece of NASA technology and use it in a way that you've never thought of. So I think those are my 2 key points on that: tech transfer and educational outreach.
Next question. This gentleman back here.
Hello. I work at Ames. I work in molecular biology, but my background's in economics, and I happen to think of regulatory systems as a type of technology, and I think this might be a little far afield, but if you plot...
Could you want to say your name, or you want to...
Joseph Grace. Joseph
Okay.
Grace. Hi, everybody. If you plot kind of measures of economic health along next to, say, strength of property rights and rule of law, you get a really strong correlation. And it changes with time based on the change of regulatory system that you're dealing with. And if you were to put space as a place on that graph and compare it with countries, it would look pretty bad. The regulatory system that's in place up there was basically developed during the Cold War to ensure, okay, you know, we don't want you to build a moon base, you don't want us to build a moon base, let's split the difference. So, you know, shared trust for all mankind is really cool and all, but it does not promote development. And I think that, you know, if you're going to talk about capitalism as sort of a way of encouraging development, like these technologies, the most technologically dynamic places in the world are all places where people know that they're going to be rewarded for putting things out there. And we have a problem with that in space.
Real quick, I'm not sure if I heard a question in there, but it's obvious that you've never dealt with the FDA.
One of those guys, I apologize.
Try applying a medical device to the FDA. It's not a problem exclusive to NASA. I would just throw that out there.
No problem.
So I'll make one comment on that. There's no doubt that regulatory restrictions for doing things in space or different destinations beyond the Earth's surface are extremely challenging and convoluted and as difficult as getting a new drug through the FDA, I would guess, although I don't have personal experience on both sides of this. One thing that I will say is I do look at some of our adjacent capability areas. For example, you know, look at wireless, the wireless domain. I mean, there is a hunger and a demand for frequency spectrum that is unbelievable. I mean, there's competition there. Everybody wants a piece of that pie, right? I mean, and you know, everyone from Google to, you know, the smallest wireless company is looking for a slice of that pie. And because there's that demand. The regulatory situation there is changing because there's a lot of pressure to change it. I put it to you that it's up to us, the folks that are part of this community, to provide the pressure for that regulatory change. In other words, let's build lots and lots of CubeSats and say, we want to go fly these because these things can make a complete transformation in the way we do things in the future. If we create that space of capability, then we will have the pressure to change those regulations. Without that, there's no government motivation, or for that matter, anybody's motivation to change those regulations.
One quick last final thoughts, 15 seconds each person, and then we'll wrap it up. Any final thoughts? Anybody going to add?
I would say, so we're near the coast, and if you ever see surfers out there, they know when there's a wave, sometimes they need to paddle fast to catch it, or else they might as well just not do it. I feel like this is one of those times where this is a good time to paddle fast. Other times when there's no wave there, paddling won't get you anywhere. It's just a slow swim. But this is a good, I think, like I said, with a lot of the technologies we've seen coming here, it feels like a good time to start paddling. So don't be discouraged. This is the time to, get your energy.
So I completely agree with that. I mean, with the recent success in space and SpaceX and the changing economic, situation that we have to change and we have to adapt if we want to achieve the goals that we have. And one of the best ways to do that is become more educated about the limiting factors that we have here. I also think that VCs and investors who are on the private side need to get more educated so that they can invest in the right things. And I can help with that. Todd?
So I guess my one quick point is a lot of the overhead and obstacles that you see to the technological development, whether that is tech transfer or regulatory, whatever, it's really easy to pick on NASA. But I will tell you from working in different industries, these are problems that are in every large corporation, in every sector of industry, anywhere you want to work. These are not exclusive to NASA. I think they're handling it as well as they possibly can given the size of their organization. And I would rather be on the other side pushing for the progress rather than dragging my feet complaining about the process. So I think that's my one quick point.
I'll end it by just saying that NASA is here as a partner to the entire space enterprise community. That's everybody from one guy that's working in a garage all the way up to the big aerospace companies. We're here to partner with you guys to figure out solutions to all of these things, whether it's regulation, whether it's providing new technologies, whether it's demonstrating those technologies, whether it's enabling new capabilities, whether it's pulling new people into our domain. Because if we don't have a turnover of new ideas and new people, we're not going to get anywhere. So we're here, and if we need to change, if we need to make adjustments, we're all about listening to figuring out how to do that.
So thank you to our panelists. And if anybody wants to send James any feedback, you can get a hold of me, and I'll help you. So, since that was an implied invitation I heard there.
All right, let's thank our panelists one more time.